Hello students, welcome back to my channel. In this video, I am going to discuss in detail about the covalent bond. Lewis proposed the covalent bond. A covalent bond is formed by the sharing of electrons. So, a chemical bond which is formed by the sharing of electrons is called as the covalent bond. Generally, a covalent bond is observed in hydrogen molecule and it is also observed in nitrogen molecule, oxygen molecule, HCl, water molecule, ammonia. Especially covalent bonds are present in organic molecules such as methane, benzene, etc. So let us see the formation of hydrogen molecule. During the formation of hydrogen molecule, let us consider the atomic number of hydrogen. It is 1. Its configuration is 1s1. So, in order to attain stability, it requires helium configuration and it is lack of one electron. And remember that always the electrons present in the outermost orbit participates in chemical bonding. And according to Lewis dot model, the electrons present in the outermost orbit will be represented either by using dot or cross. So, each hydrogen atom is lack of one electron. That means they contains only one electron in the outermost orbit. So let us see the formation of hydrogen molecule. So each hydrogen contains only one electron in the outermost orbit. So each hydrogen contributes one electron for the sharing. And the electron pair becomes the common property for both hydrogen atoms and the both hydrogen atoms acquires stability. So, a single bond is present between the two hydrogen atoms and it is sigma bond. Is it clear about the formation of hydrogen molecule, students? Remember that during the formation of covalent bond, each atom contributes equal number of electrons for the sharing and the shared pair becomes common property and it will be accounted for the stability of both the atoms. So, a single bond is formed by the sharing of one pair of electrons. That means by sharing two electrons between the two atoms, a single bond will be formed. So again, this covalent bond can be classified into two categories. If a covalent bond is formed between the atoms having similar electronegativity values, then it is called as non-polar covalent bond. So covalent bond can be classified into two categories. One is non-polar covalent bond and the other one is polar covalent bond. In general, if the electronegativity difference between the two atoms is less than 1.7, then it results in the formation of a covalent bond. Here, non-polar covalent bond is formed between the two atoms which are having almost similar electronegativity. That means between the similar atoms, generally a non-polar covalent bond is present. And the best examples are H2, N2, O2, Cl2, Ef2, etc. So all these molecules contains non-polar covalent bond. Even the organic molecules such as methane, benzene contains non-polar covalent bond. Coming to the polar covalent bond, if the electronegativity difference between the two atoms is high, then it results in the formation of polar covalent bond, and in general HCl is good example for polar covalent bond and the other examples includes water, ammonia, etc. These are good examples for polar covalent bond. Is it clear about the classification of covalent bond, students? Let us see the formation of O2 molecule. So, what is the atomic number of oxygen, students? Its atomic number is 8 and the configuration is 1s2, 2s2, 2p4. And remember, students, only the electrons present in the outermost orbit participates in chemical bond formation. So, 6 electrons are present in the outermost orbit of each oxygen atom. And remember that we have to use Lewis dot model. So, coming to the first oxygen, how many electrons are present in the outermost orbit, students? 6 electrons are present. So, it requires 2 more electrons to acquire stability. In the similar way, other oxygen atom also consists of 6 electrons in the outermost orbit, and it also requires 2 electrons to attain stability. So, during the formation of O2 molecule, each oxygen atom contributes 2 electrons for the sharing. So, let us see the formation of oxygen molecule. So, each oxygen contributes how many electrons? 2 electrons. And with the result, how many electrons are shared between the 2 oxygen atoms? 4 electrons will be shared between the 2 oxygen atoms. So, these 4 electrons counts for the stability of both the oxygen atoms. So, they can also be represented as O double bond O. So, a double bond is present between the 2 oxygen atoms. First one is the sigma bond and the second one is the pi bond. So, if a double bond is present, how many electrons will be shared between the atoms, students? 4 electrons. Do you know how a sigma and pi bond will be formed? Sigma bond is formed by the head-on overlapping. So, how a sigma bond is formed? Through head-on overlapping. So, sigma bond can be present between s and s orbitals, or it can also be present between 2p orbitals. And coming to the pi bond, a pi bond is formed by the lateral overlapping. That means it is formed by the sidewise overlapping. So, a pi bond is formed by the lateral or sideways overlapping. So, between sigma and pi bond, always remember, students, sigma bond is having greater strength than the pi bond. So, sigma bond is having more strength when compared with the pi bond. So, sigma bond is stronger than pi bond. Is it clear, students? So, during the formation of oxygen molecules, how many bonds are present? 2 bonds are present. One is sigma bond and the other one is pi bond. Let us see the formation of nitrogen molecule. So, what is the atomic number of nitrogen, students? Its atomic number is 7. And hence the configuration is 1s2, 2s2, 2p3. So, how many electrons are present in the outermost orbit? 5. And each nitrogen atom requires 3 electrons to attain the stability. Each nitrogen atom contains 5 electrons in the outermost orbit. And they require 3 more electrons. So, each nitrogen contributes 3 electrons for the sharing. So how many electrons are shared between the two nitrogen atoms, students? 6 electrons will be shared between the two nitrogen atoms. Clear, students? So with the result, a triple bond will be formed between the two nitrogen atoms. The first one is sigma bond and the remaining two are pi bonds. Now tell me, students, how many sigma and pi bonds are formed in nitrogen molecule? 1 sigma and 2 pi bonds will be present. How many electrons are shared between the two nitrogen atoms, students? 6 electrons will be shared between the two nitrogen atoms. And always remember that the electrons which are not participating in the bond formation are called as lone pair of electrons. So, the electrons which are not participating in the bond formation are called as lone pair of electrons. So, in the case of nitrogen atom, how many lone pair of electrons are present? It consists of only one lone pair of electrons. Whereas, moving to the oxygen atom, it contains two lone pair of electrons. So, how many number of lone pairs are present in oxygen atom? 2. In the case of nitrogen, one lone pair of electrons will be present. So, how many bonds are present in nitrogen molecule? 3 covalent bonds are present. So, maximum how many number of covalent bonds can be present between any two atoms? At most, only 3 covalent bonds can be present between any two atoms. Is it clear, students? So, maximum 3 covalent bonds can be present between any two atoms. Coming to the formation of HCl molecule, remember that HCl molecule contains covalent bond. It contains polar covalent bond. Clear, students? So, HCl molecule contains polar covalent bond. Clear, students? So, let us see the formation of HCl molecule. So, hydrogen is lack of one electron. It contains only one electron in the outermost orbit. But coming to the chlorine atom, it contains 7 electrons in the outermost orbit. So, during the formation of HCl molecule, what happens, students? Hydrogen contributes 1 electron for the sharing, whereas chlorine also contributes 1 electron for the sharing. So here these two electrons will become the common property and accounts for the stability of both hydrogen and chlorine atom. Clear, students? So a polar covalent bond is present between hydrogen and chlorine atoms of HCl molecule. Here the electronegativity difference between the chlorine and hydrogen atoms is high, with the result it exhibits ionic compounds properties. Clear, students? Though HCl molecule contains polar covalent bond, due to high electronegativity difference between the chlorine and hydrogen atom. It exhibits properties similar to ionic compounds. And coming to the formation of water molecule, oxygen is the central atom. And remember that oxygen contains how many electrons in the outermost orbit, students? It contains 6 electrons in the outermost orbit. So it requires how many electrons for acquiring stability, students? 2 more electrons. So here each hydrogen with 1 electron participates in covalent bond formation. A pair of electrons will be shared between oxygen and hydrogen. With the result, the oxygen also acquires 8 electrons, and hence always a covalent bond will be present between each hydrogen and oxygen. So because of sharing of these electrons, water molecule acquires bent structure. It is also called as angular structure or inverted V structure. Clear, students? And coming to the formation of nitrogen molecule, let us discuss about the formation of ammonia molecule. So how many electrons are present in nitrogen atom, especially in the outermost orbit, students? It contains 5 electrons and it requires 3 more electrons. So it contributes the electrons for the sharing. So here each hydrogen atom with 1 electron forms a covalent bond with the nitrogen atom separately. So with the result, all the 3 hydrogen atoms acquires stable configuration, and also the nitrogen atom also acquires the stability. So it can also be represented as NH3. So it is having pyramidal structure. And how many lone pairs are present in ammonia molecule, students? 1 lone pair is present. And coming to the water molecule, how many lone pairs are present? 2 lone pairs are present on the oxygen molecule. This is all about the formation of few molecules. And let us discuss about the properties of covalent compounds. So, coming to the properties of covalent compounds, generally a covalent bond is formed due to weak van der Waals force of attraction. With the result, at room temperature, these covalent compounds are available in the form of gases or liquids, or they can also be present in the solid state if the molecular weight of the compound increases. So due to the presence of weak van der Waals forces of attraction, these covalent compounds exhibits low melting point and boiling point. Here, a covalent compound is in general non-polar in nature. So, these non-polar compounds are soluble in non-polar solvents. So, they are soluble in non-polar solvents such as CCl4, chloroform, etc. Whereas these compounds are insoluble in polar solvents such as water. Clear, students? So, these covalent compounds are soluble in non-polar solvents, whereas they are insoluble in polar solvents. This covalent bond is directional. So, what is the nature of covalent compound, students? Covalent bond is directional, with the result these covalent compounds exhibit isomerism. So, what is the nature of covalent compound, students? They exhibit isomerism. Isomerism means two compounds will have same molecular formula but they exhibit different structural formula. Let us see one example. Let us see a compound having the molecular formula C2H6O. So by using this molecular formula we can write two different structures, that is CH3 CH2OH. It is called as ethyl alcohol. So what is the name of this compound, students? Ethyl alcohol. And by using same molecular formula, we can also write CH3OCH3. It is called as dimethyl ether. So what is the name of this compound, students? Dimethyl ether. So by using same molecular formula, we are representing two different isomers, and the phenomenon is called as isomerism. This type of isomerism is not exhibited by the ionic compounds. Why? Since ionic bond is non-directional. Is it clear, students? So covalent compounds exhibits isomerism. These covalent compounds, coming to the covalent compounds, these covalent compounds are non-conductors. Why? Due to the absence of free ions. So whenever if you consider a covalent compound, for example, let us consider methane. So the covalent compound consists of molecules. So there is no chance for the presence of ions. So whenever ions are not available in the free state, they do not conduct, and hence these covalent compounds are non-conductors due to the absence of free ions. The reactions in covalent compounds are slow. Why? Let us consider one example. So these covalent compounds participates in a chemical reaction due to the breaking and making of bonds. Let us see the chlorination of methane. So it requires UV light. So in the presence of UV light only the chlorination takes place. So during the chlorination process, a chemical bond, especially when you consider the methane structure, it consists of 4 sigma bonds between carbon and each hydrogen atom. And coming to the chlorine, a covalent bond is present between the two chlorine atoms. So during the chlorination process, already a covalent bond which is present between hydrogen and carbon atom undergoes breakage, and also a covalent bond present between the chlorine atoms undergoes cleavage. Then a new bond will be formed between carbon and the chlorine atom. In the similar way, a new bond will be formed between the hydrogen and chlorine atom. So on the whole, here the chemical reaction of covalent compounds involves breaking and making of bonds, which is a slow process. So these are the properties of covalent bonds. If you like the video, don't forget to like, share and subscribe. Thanks for watching. Have a nice day.